myTectra tutorials. In this section of our videos, we'll be helping you with learning some of our key courses like Artificial Intelligence, Machine Learning, Data Science, and Python programming. We hope you'll find these videos beneficial in upscaling your skills. Do like and share this video. Also, don't forget to subscribe to our channel for more tech updates.
Okay, so yesterday, let us revise what we did, what all we did. What did we start with? Regression. We started with regression, right? What is regression? What are the keywords in regressions? Residuals, also known as errors, right? Then sum of squares, very good. Then
finding the best model.
Finding the best model, that is different thing. There in regression, there is one more thing I have mentioned about optimization scheme, right? Which is the optimization scheme we use? Gradient descent method. What is gradient descent method used for?
To find a minimum.
Perfect answer. So it is also asked in interviews this way. So this is the answer we expect. What is the optimization scheme used for, or what is the role of gradient descent method? It is to find the minimum sum of squares. For that, what it has to do? Suppose I am saying fit a linear regression. What is a linear regression?
Finding a line with the minimum.
Right. Find the line, right? So for finding, they are just giving it back. We are just revising. So for finding this line, don't worry, it's just suggestion. So for finding this line, what is the equation of line? Y is equal to mx plus c, right? So what is y here? When you say y is equal to mx plus c, what is y?
Y is some points.
Y is output, right? In okay, what I'm trying to get from you is actual and predicted. What is this y here? Y is equal to mx plus c. What is this y which we are calculating? It is the predicted one, right? We are making this model. We are saying to pass a line between this, right? So the y here is the y predicted. Yes. Okay. All of you are with me, right? This y is equal to mx plus c. That y is predicted, right? What is the role of optimization scheme here? To find the value of m and c, such that our y act minus y pred whole square, sum of it is equal, is less than, sorry, is minimum, is the most minimum. Okay. So there is one more question. What is the objective function in your optimization scheme? What is the question I am asking? What is the objective function of your optimization scheme? So what should be your answer? It is minimum sum of y pred minus y act whole square. Are you all able to visualize what I am trying to say? Objective function. So objective function of your optimization scheme is to find the minimum of sum of squares. That is your objective function. So what should be the ideal value of minimum of sum of squares?
0.
Perfect. It should be 0. Y pred minus y act should be 0. So yesterday I had made one line between 2 points, right? So you intuitively said pass it over them. Only one line can pass it, right? Why? Because y pred minus y act in that case would be 0. All of you are very clear, right? Okay. After this, I started with something called performance metrics, which is what? Performance metrics. Okay. In performance metrics, I started with something. What is that? R square. Yes. Before that, variance. Okay. Before that,
mean square.
yes. What did I start with? Mean square error. It is also known as MSE. Okay. So what is MSE? Sum of squares divided by number of data points, right? So you are finding out the average error in your sum of squares, right? So suppose I am passing a line through all of you, right? So all of you will have some errors. All of you will be away from that line, the railway track, correct? how far you will be little more farther, he will be little less further, right? You same way with you, same way with you may be on the line itself, right? So for your case, the error will be 0. For his case, it will be little higher. For your case, it will be more higher, right? But in order to see on an average, what is that? What I will do it? I will divide it by the number of data points or number of students here. Are you all with me? So that is mean square error. Okay. Some also report the root mean square error. So what they do is they take the root of it. So what is that called? It is called RMSE. What is it called? RMSE. Okay. So what are the performance metrics? One is mean square error, root mean square error. Okay. What is root mean square error? Taking the root of y pred I minus y act I divide by n whole square, and here you will have the summation I equal to 1 to n. Right? What is this? This is root mean square error. So any model you make, suppose I'm making this track, right? What will you do first? You will check the mean square error. Mean square. Okay. A more complicated form of this is y pred I minus y act I upon n whole square, and here it will be sigma I equal to 1. And what is this? Root mean square error. N will be, it will not be in the square, it will be different. You are taking the square error, mean of the square error. Okay.
So that square
Is only for this y pred minus y act. It's not for n. Okay. So till here we did, and then I started with, what did I start with? R square, right? See, I'll just explain you. MSC is what? Without the root. This becomes MSC. RMSC is what? With the root. Okay. Same way, R square is also one. It is also called coefficient of determination. What is it called? Coefficient of determination. You may note it down. They may ask you. So I started yesterday with R square, which is also called coefficient of determination. What is the formula for R square? Yesterday I made you write, or made you
Variance of mean minus variance of
variance of mean minus variance of fit upon variance of mean, right? Okay. So we'll build on that today. Okay. For your assignment, I think one of you had asked me also. We can take the modulus of, you had asked me, right? Yeah. You can take the modulus instead of square. We can do that also, but I said it leads to problems in optimization. Okay. May lead to problem in optimization. Okay. So I am giving you one assignment. The assignment will be, you have to find out what is MAE. Okay, find out what is MAE. It is mean average error. So that is your assignment. Okay, so I am going to start with R square today. R square is nothing but variance of mean minus variance of fit upon variance of mean. Okay, what is variance of mean? Or you can also say it is 1 minus variance of fit upon variance of mean. Right? 1 minus variance of mean upon variance. So yesterday I had laid the foundation for this, right? I said whatever we are doing in regression, right? What is our reference? The reference is the most simplest model we can make. What is the most simplest model we can make? The mean model, the statistical mean model, median model or mode model, whatever you take. The most simplest is mean model. So R square basically gives you what? It gives you how good you are with respect to the mean model. Or the other way to think about it is, how much have you reduced the variance from your mean? I explained this also yesterday, right? Suppose I am standing here, okay? The railway track is here. This is the main track, okay? I am away from all of you, Okay. So what I'm saying is, suppose I'm standing here. This is the mean model, right? I am some distance away from you. Okay. Now, suppose I shift myself to between them, right? I have reduced the mean variance. Can you understand that? When I'm here, the distance I'm there from you is much higher. When I'm coming there and standing between you, the variance, the distance from each of the student, the sum of that will reduce, right? Similarly, can you visualize that variance of mean, right? You will have that line. Yesterday I had shown you as it started. Okay. So that line, okay, let me draw it. Okay. So what are we going to talk about? R square value. It is also called what? Coefficient of determination. Why are we calculating it? What is the objective of calculating R square? How good our model is, or how good our model is with respect to mean. Very good. Okay. Right. So now, what variance? What is variance formula? Yesterday I made you write that also. Let us write that. So it will be what? Sigma I is equal to 1 to n y act I minus y mean upon n whole square minus sigma I equal to 1 to n. What will be this? Y act I minus y pred I, right? This is for the line now. Whole square, sorry, by n whole square divide by sigma I equal to 1 to n y act I minus y mean upon n whole square. Is it clear? Now if you see, here n square will get cancelled. Yes? Okay. So this formula you can also write as SS mean minus SS fit upon SS mean. Are you able to see what I'm trying to say? SS is what? Sum of squares, right? So that is what, nothing but I equal to 1 to n y act I minus y mean whole square. That will be SS mean, right? Or this will be equal somewhere, some may also write it as 1 minus SS fit upon SS mean. Is it clear or not? Okay. So what I was trying to explain before this was, you have this line, you have this x's, these are your data points, right? Which is your mean model, passing somewhere like this. This is your mean model. Make sense, right? Let me take better data points. Suppose something like this, right? And now your mean will be somewhere. Is it clear to all, right? What is this? Your x. What is this? Your y. This is your y mean line or your y mean model. It doesn't change with x. Whatever time I am coming to the class, you will say average is 8.5 plus minus 2 minutes, something like that, standard deviation, right? So this is your y mean. Now, what is variance? Variance is nothing but calculating this distance. So what will be the total variance? So say 1, 2, 3, 4, 5. It will be sum of this I equal to 1 to 5 y mean minus y act I divide by n whole square, right? Now, till here, is it clear? Sorry, yeah. Now let's make a regression line. Let's take the black one. So how will your regression line be? Something like this. Let's take this. Something like this, right? What will be the variance in this case? It will be from here now. Yes. So if you see, the variance will reduce from the mean, right? Your variance will reduce from the mean. I even don't need to give this yellow line so big. I can also show it this way. Control. Okay. So instead of this, even if I show that your y mean is here, it is okay because the value will always be this, right? Are you all able to see? So now you are basically calculating your variance from this point for all the points, right? And you now have the regression line, right? So R square is basically giving you statistically how good your, or the other way to think about it is, how have you reduced your variance which was there in mean by fitting a line or fitting a curve? It may be a polynomial regression or something. Are you all getting what I'm saying? So one way of thinking it was, how better have you modeled with respect to mean model? The other way to think about it is, how much have you reduced the variance from your mean? Yeah, your variance, there was some variance when you had the mean model, and now with your fitted model, you have, how much have you been able to reduce it? Is it clear? Right? So suppose he has reduced at some point and you have reduced it to some point. Out of these two, the one which gives me higher reduction, so that the value of variance of mean minus variance of fit is higher, that I will choose as my model. Does it make sense intuitively to all of you? So basically, I will choose that model which is giving me the reduction in mean the most, the variation in mean, reduction in that the most. Is it clear or not?
So you're saying R should be maximum.
R should be maximum. Why? How ideally what should be the value? Okay, I think you'll understand here better. Ideally, what should be the value of your SS fit? Ideally, SS fit. Ideally, what should be a value? No, it should be equal to, it should be minimum, right? What is the minimum we can reach? 0. Obviously, the fit has to be y pred. Okay, look here. I think it becomes more clear. Y act I minus y pred I. So you will want that line which passes through all your actual points. So this you would want it to be 0, ideally, right? If this is 0, suppose you have reached this 0, what does this become? SS mean upon SS mean, which is nothing but 1, right? So ideally the maximum value you will be able to reach is 1. Are you all getting the idea? What will be the least value? Assuming the model which we make cannot be worse than SS mean, okay? Assuming that, so don't worry about that. What is the worst model I can make? The worst model I can make is the SS mean itself. So I am fitting a line, but that line is the variance in that is as good as the mean model. Are you all getting the idea? So I am coming to the class, you are saying the average time of me coming to the class is 8:05. Now you take all the factors in the world, what is density at Silkboard, what time I started, what time I ate, what time I slept, everything you take. But at the end, you are still predicting 8:05. So it means what? All this doesn't make any sense. I mean, it's better you take the average model itself. Why are you doing all this complex mathematics, right? So in that case, your SS mean, SS fit will be equal to SS mean. And this is an assumption that this is the worst you can predict, the SS mean. So SS mean minus SS mean upon SS mean, what will be that? It will be 0. So ideally, your R square value will be 0 and 1, right? So when I said that out of these two models, which is the better model, then what I will compare, essentially, if you see, SS mean will always remain same. If I am comparing from the same data set, two different models, one model is ML1 and the other model is ML2, okay? Why different models? So say someone has done different kind of outlier processing. Are you all able to understand my language? So suppose he has replaced the missing values with mean, and he has removed the missing values. Okay, and I have replaced the missing values with mode. So all three are different models now inherently, right? All now I will have to check as a data scientist which out of these three is the best one, right? So now are you able to feel it that R square will give you that idea, right? So for me, my case, R square may come out to be 0.9. For his case, it may come out to be 0.86. And for your case, it may come out to be 0.95. So which one will I select? First, 0.95. Or you will understand intuitively that yes, this 0.95, it means this is able to reduce or give me better model with respect to mean model, right? So I will select this. But essentially in all three of us, SS mean is same. The mean model will always be the same, right? What is changing is SS fit, right? Now what is SS fit? Y act I minus Y pred I whole square, right? If you see, this is nothing but MSC. This is nothing but the MSC. If I just, instead of this n square gets divided, instead of that I just divide by n, this is becoming MSC, okay? So what I'm trying to say is, even if you're measuring MSC instead of R square, so essentially for the same data set, you're doing the same thing, right? For me, R square value will be, MSC value will be say 1000, okay? For him, it will be say 1020. For your case, it may be 950, right? So which is giving me the least mean square error? You are giving me that. So that is essentially the same thing. But statistically, it makes sense in order to compare with 1 lakh or depending on the data set, it is easier to say, have a number between 0 to 1. So what we are doing is nothing but normalization of it. Okay? Yeah. Yes.
So how is it? Because outlier is contributing to the mean as well, right?
R square is here.
No. Outlier is contributing to mean as well.
Right.
So if I will be removing the impact of outlier, the mean will be adjusted, predict will be adjusted, divided by mean, right? So ultimately, R square will be adjusted.
Right. So with respect to R square, so what he is saying is,
Shall we remove the outliers from mean also?
yes, obviously. So that is pre-processing, no? But he is saying, suppose, let me make it. So, and you have some point here, which is your outlier, right? In this case, this will, no, this, yeah. So in this case, the mean may still remain the same if you see.
No, if I remove the outlier, the mean will be changed.
Right. In this case, this is the outlier, right? Right. So with respect to X, but if you see with respect to Y, it is still in there. Are you getting what I am saying? Here we are calculating Y mean. We are not calculating X mean.
No, that is fine. Simple case is that you are coming regularly at 8:10. That's a mean time, and that's because once in 30 days you came at 8:45, and that's why your mean is drifted
Right.
to 8:10.
Right.
Actually, if I remove that particular outlier,
right,
your time will be moved towards 8.
Right. Right.
So mean will be moved.
Right. But that mean will be moved. So suppose that is bad for you. Let's take that one now. Suppose you assume your outlier is somewhere here. Right? So most of the time I come in this time between say 8 to 8:15. Right? And once it became at 8:40. Instead of 8, I came at 8:40. So this becomes like an outlier. Right? So what will happen? Your mean will come up somewhere here. Or let's say it may even bring it to here. Right? In this case,
and I created a linear regression line. For that.
Right. So if you create, yeah. So let's take this point just to bring out my point. So just to bring out my point, let's take it somewhere here. Then it will not be an outlier. So somewhere here. Okay, so this is just for your visualization. So suppose this is an outlier, right? On some day I came at, okay, it is also an outlier. Actually, this is not an outlier. This is an outlier. Why this is an outlier actually? Because here suppose I am drawing the traffic density at Silk Board, right? Which is between 0 to 1, right? So suppose most of the data points when it was very high, Silk Board density was say 0.8, I still came at 815, right? But that day I came at 840. So even if the density was 0.8, I came at 840, then it is qualifies to be outlier. I hope you are getting what I'm saying, right? Because in spite of having the same traffic density, I came at a very late time. I may have spent time drinking tea or something of that sort, or someone has stopped me and then I came late. Are you all getting the idea? Right? So this qualifies to be an outlier in that case, right? So, but what will this do? It will bring my mean model up somewhere here, right? And in order to accommodate this, I may have to fit a regression line, which may fit like this, somewhere here, like this. Suppose, okay? Now, ideally, I should have got a regression line, something like this.
No, so question is that till now your R square will be higher, right? Now, if
No, R square, I'm not saying about R square also. Your R square will be higher. Why? Because majority of your data points is between 8 to 850. So the variance with this, so in order to accommodate reduce the variance of 1 point, you are going to have cumulatively higher R square, lower R square value, because this variance will increase, which is major. So in order to accommodate him, suppose I pass a line here, I'm going to have larger variance with my other actual data points. I hope you're getting what I'm saying. So in that case, your R square will automatically come down. Even though your mean model has changed now, your R square model will also come, will have a tremendous effect on your R square. I hope you are able to understand, right? It is basically one guy I'm trying to adjust and the other data points will be far off. Now, if I remove this guy, I can pass off from here and obviously now majority are here. So my SS fit will reduce drastically. Though my SS mean has changed now, but that mean has changed very small. I mean, what in respect to the change in SS fit. So it is basically a play between SS mean and SS fit. Okay. So I have completed what was I explaining? Yeah, I was about this. So I was saying inherently, if you measure MSE, RMSE and R square, they are inherently the same. I mean, if you can see why I'm saying, suppose the mean model doesn't change. Like how I said, the example I gave was the missing values I have handled, these 3 models are different. So, but the SS mean for all the values may be same. Is it clear or not? Okay. Now, I wanted to come out into what is the assignment given to you here? Work on MAE. Okay, read more on it. Okay. So now, let me come to the disadvantages of R square. Yes. Yeah.
So you were actually, so you were actually telling how to do the normalize, right? We were talking about how to reduce the noise of outliers, right?
No, I have not spoken about that.
Then how actually we will be doing it if we need to remove the outliers? How would we figure out that there are outliers?
No, that we have done. No, Z score will take plus minus 3 sigma, or we will see the quantile method, and then we will remove. So suppose one student of mine is sitting in that classroom, and majority are sitting in this classroom. He will come in the 5 percentile, end 5 percentile. So I will identify that guy is sitting in next room. Let me remove that guy, or tell him, request him, boss, can you come here? So I will replace him with the mean value of all.
Got it.
So removing outliers is a different strategy. It has nothing to do with R square. R square is just performance metrics. Is it clear? Right? Yeah.
And then how about, the normalization and scaling things works with, to do, remove this ambiguity or anomalies? I mean, how
Normalization or standardization is for different things. I had explained in one of the class. Have I? No. So I'll come to it later, maybe. Okay. Let's not. I will create that story also. Let me finish this story. Is it clear to all of you? Right? Okay. Actually, when in encoding, I had slightly given a hint of that part. So in encoding, if we do categorize, if we give numbers to categories. So suppose I have a data set in which I have electronic items, mobile, fashion accessories, something, something, something. So one way of encoding it is what? I give mobile as 0, fashion as 1, household items as 2, something like that, right? But then I said this goes as numbers to the ML model, to the regression model, right? So what it will understand it as numbers. So it will increase your weightage to the, say, household items unnecessary. Are you all getting? So what we do, we go for one hot encoding, right? What is one hot encoding? Creating vectors of 0, 1, 0, 0, 0, 1, etc. All of you with me or not, right? I said there is one get dummies also. How many of you were able to run the code I sent? You ran? In that there was pd.get underscore dummies. Yes. Right? I will come to that when we will, after this we will use that data set to create, after pre-processing, the ML model. Okay. So when I come to that, I will make you run through that also. Okay. And we'll do some examples on pandas also. One more file I had given you, which was basics pandas, some functions of pandas, right? That is an online one. I also gave you one myself. I have created one file, pandas underscore 1.py file. Okay. Anyways, let's not go digress. Is it clear what I was talking about? R square. Now, what I wanted to say was the disadvantages of R square.
So forward that actually I do not have.
Sure, I'll do that. Suppose what model we are trying to make? We are trying to make, say, traffic density of silk board and the time I reach class, right? Suppose there was one more axis, right, which was taking into account how many child were born at that point of time in India. What is this line saying? Number of births at 8 a.m. or say 7, number of births at 8 a.m. or say 7:50 a.m. when I reach Silkwood. Does it make sense? What is the third axis? Number of births of child in India at 8 a.m. when I reach Silkwood. Do you see this will help anything to my model? This has any correlation to my model? No. Suppose I say one more axis is what I flip to the coin, I got heads and tail. Before moving from the house, I flipped a coin, I got head or tail. Or suppose you want to predict, you say I flipped a coin and today it is head, then he may come after 8:10 and before tail. Does it make sense?
No.
No. Are you all getting what I'm saying? So even if you have number of parameters as high, okay. So in this case, what will be your model? Your model will be mx m1 x1 plus m2 x2 plus c. Are you all able to follow? What is x1 here? Traffic density at Silkboard. What is x2 here? Number of births in India, right? What will happen intuitively when you do when you do optimization, M2 will be coming 0. Okay, if it is not related with your Y, automatically, mathematically, M2 will tend towards 0. Okay, so your model itself, which will be predicted, will come out to be Y is equal to M1 X1 plus C. Your M2 will tend towards 0. Are you getting the idea what I'm trying to say? Your regression will automatically find out M2 as 0, right? But what are we tracking? We are just tracking R square now. Suppose these 3 models are there, right? You have taken a decision because you had the domain knowledge that X2 is not important. I will not take it in my model. He removed it. Okay. What he did, he dropped it in pandas term. df.drop. He will drop that column from the data set. Does it make sense? I don't have any domain knowledge. So for me, suppose he had just given me, instead of traffic density, the manager just gave me this is X1 and this is X2. He didn't explain me what is X1 and X2. So as a data scientist, what I will do? Hey boss, I don't want to miss any information. Let me take X1 and X2 both in my model, right? But X2 is not good. Okay. I am just tracking the R square value. Okay. Do you think there will be a difference in R square value of what he created without X2 and what I created with X2? No, there will be no difference. Why? Because this will be 0. So I got 0. My model will say M2 as 0. His model he didn't take only. So his equation is M1 X1 plus C. My equation is M1 X1 plus M2 X2 plus C. But my M2 will come towards 0. Okay, it may have some small value 0.001 or something, but it will tend towards 0. Are you all getting what I'm trying to say? Because it will see that change in X doesn't change your objective function. Your objective function is Y pred I minus Y act I. So inherently in your optimization scheme, what it does is it varies X2. It keeps X1 as constant. And it sees whether your your objective function is changing or not. So in that case, it will find out whatever X2 value I put, my objective function will not change. Okay. If you are not able to follow, it's okay. Are you able to understand? Right. So in that case, it will tend M2 towards 0. Anyways, so M1 still, did you understand what I explained? When optimization will work, what it will do is it will vary X2 keeping X1 constant. The machine will do that. Okay. It will see I am varying X2 or I am varying M. Suppose not X2, I am varying M, but it is not making any change in my sum of squares. Obviously, today I had heads or tail, or today there was no birth in India or there was birth in India. That will not make a difference to what time I reach the class, right? So my objective function will not change. So that is how it will find out that M2 keep it as good as 0. Okay. Unless you are using some bad optimization scheme, but that is a different area of study. Okay. So what I was inherently saying, what you need to remember is, he didn't take X2 because he had the domain knowledge. X2 is not important. I took X2 because I didn't know that. So I just took it in my model to be safe in case X2 was, suppose, what time I slept last night. So then it becomes a very important, or how many classes I have, something like that. But the manager has given me data set as X2. So I will not want to miss that. So what I will do is I will put it. As a data scientist, if you are just measuring R square, what will happen is his R square value and my R square value will be same. Okay. So I will not be able to understand the effect of parameters. Okay. Whether X1 or X2 is important or not. Is it clear or not? So in short, what you need to remember, the takeaway line for you is R square value doesn't show or doesn't exhibit the impact of parameters. So suppose in this, there was one more data given to me. What is, maybe give me some random data which is not related to this. So whether, whether in US, suppose it rained or not. So what is the fourth axis here? Whether in US at 8 a.m. there was rain or not in US San Francisco, suppose, right? Do you think it is related to me, right? So he created a model which was having M1x1 plus M2x2 plus M3x3. What is M3x3 for him? Whether it rained in San Francisco or not. Okay, so obviously even his M3 should tend towards 0, right? But R square value of all three models will be more or less same. For him it will be 0.90, for me it may be 0.899 or 0.901. For him it may be still 0.90. Okay, are you all getting the idea? I have also explained you how it is coming, because you don't have the domain knowledge of the data set. You don't know whether this is San Francisco rain or this is Bangalore rain. Does it make sense? Right? So R square value, if you are just tracking, it will not help you in that. Okay. So for that, you have the concept of adjusted R square. Okay. Adjusted R square takes into account the number of parameters. Okay. So the second assignment for you all is, I want you to write and understand the formula of adjusted R square. Okay. So if you see the formula of adjusted R square, it will take into account N. What is N? Number of parameters. Okay. So it will find out, what it does is, it will compensate the increase in, so with R square, what was it happening? I was all three getting 0.90. So we don't know which parameter is not making a difference to our model, right? Adjusted R square will take a factor N into it. So he had 3, I had 2 parameters, he had 1 parameter, right? So he will penalize him for getting the same R square value with N equal to 3. Okay, so that is taken into account in adjusted R square. I want you to search for it, spend some time. This will be my assignment. This is my trick so that you can study some time this week. Is it clear or not? Yep. Okay.
My prediction is X2 and 3X3.
Yes.
X3 unpredictable. It's the outlier.
Yes.
Okay. How it's affect the M3? Because you are saying M3 is going to 0.
It will tend towards 0. Yes. Yeah. So what's your question?
So just why is it towards 0?
I just answered him. What? So there is one optimization, gradient descent method taking place. So in that, what it will do is, it will vary your M3, keeping M1, M2 constant. Okay. So when you vary M3, you should have some variation in your Y. So suppose, let's take this example. You had the parameter whether it was raining in San Francisco or not, right? Now, suppose it rained heavily, there was flood in San Francisco. Will it affect what time I reach here? No. So my Y pred will not change, right? So the computer will do that. The machine will do that. It will vary the San Francisco data and see whether my Y is changing with that. So it will find out there is no correlation. So M3 will tend towards 0.
So adjusted R2 score will start reducing with unrequired.
That is an assignment I would want you to spend time.
How does the implementation of gradient descent?
I will have a different class on.
So that's the default optimization, and then probably there would be ways to change it.
Yes, but sklearn basically gives you gradient descent. We may have one short class on it. I will not go. I can go into as much depth, but yeah, I'll give you an understanding how it works. Okay. So there are different methods also within gradient descent method. Adaptive gradient descent, batch gradient descent. I'll explain that. Is it clear till here? Okay. The other fault of R square is, suppose you have 2 points. Let me use this line. So suppose this was your line and there was only 2 data points. How many? 2 data points. How many lines can fit through it through optimization? Only 1 line, and it will end up with this. Right? What will be the R square value for this? 1. It will be 1, right? So if we get a value of R square as 1, right? Why did we get that? Because there was no other option. What I'm trying to say is, suppose you had 3 data points right? And then all of them are say on the same line, or there were 100 data points, not take 2, 3. There were 100 data points and the same line is able to pass through it. Then R square equal to 1 makes some sense. Why? Because there were 100 data points and you were able to fit one line to it, right? But suppose your number of data points itself is low, that it is only 2, then optimization has no other way but to go to that line. It will find that line only always, right? So R square, that value as 1 statistically is not important. Why? Because you didn't have any other option. Okay. So for this we do something called p-test, whether your R square value is significant or not. Okay. I'm not going into the detail of that, it's not required, but I want you to understand what is p-test used for. Are you getting what I'm saying? P-test is a test hypothesis which we do to find out whether my R square value is significant or not.
Use the percentile of the significance level.
Which one?
The p-test use the significance level.
Yes, significant. So if it is below 0.05, then it is not important. If it is above that,
Okay, so do we need to do something multiplication of the significance level with R square to get the real sense of what exactly R square is making sense to me?
I never did that, but I have not done
Is
that.
it the right direction of thought?
No. So test is basically giving you what R square value is significant or not. So if it is less than this, if it is less than 0.05, we'll say it's not significant. If it is higher than 0.05, we say it is significant. So it is like probability. So basically it gives you whether your R square, whether you had any other option other than that line to make. So if you had 5 options, okay, and then if you get a R square, if you get the most optimum line, then your P value will be very high. So you will find out, okay, this was something he found out. There was other options, but he chose this one. But if there were only 2 data points and 1 line can pass through it, your P value will be very low. Okay. So why I'm not going into it, it's not required. It will confuse you. So what is in industry point of view, most important is R square. Okay. People check R square only most of the time. But yes, I don't know why people don't see. I always make it a point to quote I adjusted R square also. Okay. Why? It gives me the impact of number of parameters. Is it clear or not? Right? And they may ask you in interview, how do you see, or how do you, what is the performance metrics for your regression model? So what should be your answer? Your answer should be mean square error, root mean square error, or R square. Okay.
What's the significance of having the R square and because we have the adjusted R square, and here we will be using the R square over the priority of so when we will be giving the prioritize to R square than to adjust R square.
So suppose there are 3 models, okay, and your R square values are same for all 3 models, then you will go for adjusted R square to see whether number of parameters is there. And there are 3 models and all R square, for one of them the R square value is significantly high. Then it doesn't matter to see adjusted R square, because that R square value itself is saying that this is the better model. Okay.
So R square we got to know it varies from 0 to 1. What will be the varying value for mean square and mean square?
It will. So suppose the distance is in kilometers between us, then the mean square error will be in kilometers. If it is in centimeters, it will be in centimeters. So that is the problem with mean square error. It doesn't give you, so suppose you hear that we are going to launch a rocket to moon. Okay. In that case, suppose in between there are some satellites we want to launch or something of that sort. I'm just randomly making. In that, it will be in millions of kilometers, suppose, right? The distances will be, say, in millions of kilometers, right? So your MSC value will be 10 lakh, 20 lakh, 50 lakh. But suppose I'm making here, then it may be in meters. So 10 meters, 20 meters, 30 meters. Then if someone says to you, "Hey, my model said MSC was 5 lakh. This is the best model I get." You will say MSC 5 lakh. You're mad or what? But in context to his distance with respect to moon and earth, 5 lakh is a very short distance, right? So the better way of communicating between data scientists would be what? My R square value was 0.8. My R square value was 0.9. It is just that. Okay. But for the same data set, mean square error you can compare. If you know that it is in meters, then you will understand 5 meters, 7 meters, 10 meters. Oh, 10 is very high. Let's take the 5 one. Does it make sense?
Sir, R square and adjusted R square, we calculate them for the given set of features, not
Yes.
for the individual feature. But as per my understanding, this P test we calculate that
Yes.
we get the summary of P test for the individual feature,
Yes.
not for the set of features.
So you can read more on. I'll get back to it. Okay. It will confuse others. Is it clear till here? Okay. So we completed R square. I hope you got a good feel of what is R square. You understood what are the pros and cons of R square, right? What is adjusted R square? You need to do it as an assignment. Okay. Now I want to show some. Now you are ready to the thing I want to show. Are you all able to see? You are able to see? Coupled. Online, are you all able to follow? Rajshekar,
Yes,
Deepali,
yes,
Himanshu.
yes.
Okay. Okay. So Deepali, Himanshu, did you know about this or it was a new thing? If R square not good fit for model, then if we get R square in this case, what we will do? If your R square value is 0.3, you will say it is a rubbish model. It is as good as your mean model, just near your mean model. Your R square values are good if it is more than 0.8, 0.7. I mean, you will look into it. At least you will try to see I can better it or not. So, so it will just prove that this linear assumption itself is not good. Suppose you try to fit linear regression. Okay, I will give you one example, I think.
So in that case, probably we need to change our approach from linear regression. We need to probably go.
So that is what I am coming to now. I am just showing that with the Excel file.
Yes.
Okay. But now I am good. I am happy you are able to understand that how R square gives you directions in machine learning, right? Okay. So let's take some value of X and let's take some value of Y. What is X? Your inputs. Okay. So let's take 1, 2, 4, 5, 8, 10, 12, 13, 17. Again, let's take. Okay. Let's take. I'm just randomly taking. Give me some time. This time, let me draw this. How many of you know the features of Excel file? You know this, right? So basically, I'm just plotting on Excel file. Okay. I'll zoom it. Don't worry. Oh, let me change it to a new sheet. Move chart to new sheet. Increase. Okay, are you all able to see exactly what kind of, so this is suppose your data set X versus Y. Are you all able to see, right? Now, suppose I want to fit a line on it. What I am doing basically, I am trying to fit a line means what I am trying to do regression model. Okay. So here in Excel, there is some option called add trend line. Okay. So if you see what are the option given here in add trend line, exponential, linear, logarithmic, polynomial, power and moving average. These are some option given. So by default, it is on what? Linear. Okay. Okay, by default it is on linear. Let me increase this. This is it. Format axis. No, I want to change this one. Okay, let me first do this. Format trend. Display equation on chart and display R square. Yes, perfect. Are you all able to see this R square value and the equation? Are you all able to understand now intuitively what Excel has done behind it? It has done regression and it has found out the value of M and C, if you see 0.5242 and C is what? 1.9171. What is your R square? 0.72, right? Now, suppose here the other option given to me is polynomial, logarithmic, power, moving average. Okay. So now I say my R square value is 0.72. Can I increase it? Okay. So what I will do is I will say, suppose check the next level, that is polynomial. Let's try a polynomial equation. So instead of y equal to mx plus c, what I will do, I will try to fit y is equal to mx square. Your equation of curve changes, right? So here I am changing to polynomial. Check it. What did I get? Mx square plus, sorry, m1x square plus m2x plus c. What is your R square value here? 0.81. If you see this curve, are you all able to see this curve? Just a second. If you see this curve, what is this curve coming out to be? Like this? And actually your data is like this. After, say, after your x is 15, right? It doesn't make much difference to your y. So say our age versus height. Okay. Initially, as our age increases, our height increases. Right? But after some time, our height remains constant, say after 21 or 18, whatever it is, right? Is it clear or not? So whatever our age our height will still remain the same. So in that case, do you think linear regression will be a good idea to fit? No. Why? Because linear regression inherently has this property of increasing with time or increasing with x. Is it clear or not? So in that case, you would like to fit something like a parabola, which is exactly what this code is showing, right? It is showing that with this, so now let's change this line again. Let's assume, so what is the order here? Order of polynomial 2. So I have assumed m1x square plus m2x minus plus c. Now let's increase it to 3. What is my R square value? Okay, with 2 what it was? 0.81. With linear regression it was what? 0.7, right? So you now know it that with increase, so there is some non-linearity. It is not linear. Okay, so let's try increasing it to 3. What does it become?
So where you changing?
Here in order, you see. Here in the side, there is one order 3.
Polynomial available. So
Polynomial and there is one order function here.
order what exactly it is doing?
So initially my equation assumption is if my order is 2, my equation assumption is y is equal to m1 x square plus m2 x plus c. Okay. If my order assumption is 3, it becomes y equal to m1 x cube plus m2 x square plus m3 x plus c. Okay, so you are basically increasing your parameters. If you see, you are initially linear regression, you had only one parameter m1 and c. Now with 2 you are increasing to m1, m2 and c. With 3 you are increasing to m1, m2, m3 and c.
So in simple terms, if I try to understand, this is nothing but just a number of features we are supplying.
Number of parameters of model you are increasing.
Parameters are the
Features are same.
input.
Your x is same. Your x is not changing. What changes is you are fitting more parameters to your x.
More curvy.
Yes.
No,
Yes.
but what do you mean by parameters when you say parameters?
Model parameters. So inside your model, what are the parameters m1 and c? If it is a straight line, the model parameters are m1 and c.
Right.
Right? You are finding m1. So what is your machine learning doing? It is basically giving you m1 and c. That is at the end what you are doing.
So slope and the intercept and the value of x is my
Not value of x is not your parameter. Value of x is fixed.
value of x is fixed, but that comes into that equation. So slope and intercept.
That is what you are changing with your machine learning.
Right.
So if you are increasing your order, you are basically increasing your number of parameters.
Sir, I am still sorry, I'm still not understanding. When you are saying that increasing the order, increasing the parameter, what is so there are two parameters, and C, right? X is fixed.
Yes.
So what other parameter we are talking about? Increasing the parameter means
The value of x, you can go up to x cube.
okay.
So with x cube, there is a coefficient attached. With x cube, there is a coefficient attached. That's what I just wrote, right? So you have y is equal to mx cube plus m2x square plus m3x plus c. So now you have this as extra parameter. You didn't have this in linear equation. Are you getting what I'm saying?
First it can be y is equal to c, which will be mean. Then it can be y is equal to mx plus c, which will be a straight line. Then you change other things. What you can change is x cube, x4.
So basically, you are now having this parameter extra because you have taken x cube into account. You have taken this a parameter because you have taken x square into account. When you have taken this, this becomes. So initially, only
So
this was
is
the
value of the m, right? This
Yes.
is the value of slope. So we are
So you are increasing the number of slopes. No, you are increasing your parameters.
But how to decide that whether this parameter will correspond to x3 or this parameter will correspond?
So you are getting that, no? M1 0.0024 you are getting is corresponding to x cube. This equation you will get in your model.
Gradient descent will tell us.
Yes, it will give you that.
And x cube also will tell us. So it is a coefficient.
X cube is you have decided. I am telling you fit a order 3 curve.
Order 3.
The machine didn't decide for me. I am giving this as an input.
And
machine is deciding simple linear or if polynomial it is deciding that's not decided.
you have to decide the order and get the answer and then think about whether this order is correct.
Make sense? See what you are following or not. Don't do internal discussion. Talk with me when in class. So I am doing the linear, logarithmic or polynomial. I am choosing it. Are you getting that? You are controlling what curve you want to fit. When in polynomial, I am controlling whether I want to go for 2 or 3. So what did I do? First I fit linear. What I got? 0.72. Right? Then I am fitting logarithmic. I am getting 0.81. The minimum polynomial I can fit is 2. Let's increase it to 3. 0.84. Let's increase it to 4. 0.8411. Let's increase it to 5. What it becomes? 0.8483. 6.8484. But can you see after 3, it is not making much difference. It is in the third digit, right? So does it make sense mathematically to go beyond 3. No, you are unnecessarily increasing your computational power. Are you getting the idea? Okay. So it happened to me during my PhD when I had started. I had fitted a model on one of a very complex data set. Okay. And I went to my guide and I told him, sir, see, I have fit a very good model. Okay. My guide used to be very rough with me. He told me, "Tu pagal hai kya?" मैं बोला क्या हुआ सर इतना अच्छा मॉडल फिट किया you are getting good model but then he explained me you are fitting to the power 6 right so basically he told me this dialogue that if you give me 2 parameters M and C I can fit say a rat into it okay but if you have 6 parameters you can even fit an elephant because you have more power now more variation you can make see if you don't understand don't worry
No. So how does it
just a second so now in that he said if you are increasing a number of parameters you are basically trying to you can fit anything you want into it you are having so much variation so that will be the next topic you will have so much variation that you can fit anything you want into it are you all getting the idea so if you see here the curve which I am getting with x raised to 6 it is so curvy it is able to fit anything what it wants right so but there is no challenge in it I am just increasing the number of parameters if I increase it to 10 it will fit each and every data point okay but there is a issue of overfitting so that will be the next topic so that time he gave me this dialogue that the real art lies in how you can fit in 2 data points a elephant okay how you can with a simple model how can you fit a more complex data set anyways this is higher level don't worry what are you all getting what I'm saying increasing the order will obviously increase your R square value but that is no art the art is if you have only 2 parameters M and C how you can make it much better how you can bring your 0.72 to 0.75 in your linear regression model is it clear or not? Yes you were saying something I'm sorry. Yeah.
No, that's fine. So I was just, yeah.
So if you increase your number of parameters, actually I got your question. If you increase your number of parameters, you can fit anything. Yes.
So here, as we discussed, right, so then the multiple parameters comes into the picture. Okay, but what if the multiple features are there? So for each features or all the features you will consider in the one shot?
Yes. So here x. If you go to higher level of mathematics, here your x is a vector. You don't think x as one point, as one axis. Actually, x is multi. It may have x1, x2, x3. It's a vector.
So, sir, in that case, if we go with a higher number of parameters, will it reduce the capability of predicting the next continuous value?
Yes. So that is the next part.
But it will.
So next part is overfitting and underfitting. So I will come to that.
So x is basically a vector.
Yes. You should imagine x always. I'm not telling that now because it is just others. I want you to be very simple. I hope till here the story is clear. Okay. Next class, we will start with what he has asked me about underfitting, overfitting. What will happen if we go for more complicated curve? Let me show you with logarithmic also. With logarithmic, what we are getting? 0.74, all of you, right? With exponential curve, we are getting 0.7415. So if you assume logarithmic or exponential, it is better than your linear curve, but it is not worse for your this thing. Let's say power, it is 0.93. So if you see the power model is giving you the best one.
If possible, some idea about the difference between exponential, logarithmic.
So that is just the equation. So here you see what is the model I am fitting. So with exponential, the model I am fitting is y equal to me raised to x. No, y equal to me raised to say. Sorry, let me put it this way. Y is equal to m1 e raised to minus m2 x. So you have 2 parameters here, m1 and m2. With logarithmic, it will become y equal to someone had given that data. Okay, my mistake. Anyways, I'm not able to see the chat in between, so you will have to speak. Okay. So y is equal to M1 ln x plus M2. This becomes your model if you are fitting a logarithmic. So it's just the equation changes.
And it is just a game of score to figure it out that we need to.
The first level. The first level. When your R square value is same, then you will have to dig for other parameters like adjusted R square, etc. But yeah, initially, all of you can see here now intuitively what is the R square value for this thing, power? 0.93. So as a data scientist, what you will try? You will try to see more about power. You'll check your model with, you'll take power model. So instead of linear, you'll assume a power.
We can compute this in Python, right?
Yes.
Power model and
Yeah.
model.
So initially, I will only take you linear regression, but then it will be your assignment. Okay, you have to work. This is a commitment I had taken, right? So everything I cannot make you do in the class. It will be just showing code. You have to go at home and spend some time on it, right? That is a minimum commitment you should give when you're doing so many classes. Okay. Yeah. So let me conclude now, so that I am happy with the picture I have been able to make. We started with regression. I have come to R square. R square value now, I think you have a good feel how it is helping you choose the model. Next, I will how you test your model. What is training data? What is testing data? What is overfitting? What is underfitting? What is bias model? What is variance model? Okay. Then I will come into the concept of regularization. Okay. These are slightly complicated. We will build on this. In regularization, I will go into lasso regression, ridge regression, etc. Okay. So next class, I think the next weekend we will spend on this. Also, we need to do coding. So it is upon you. Do you want me to code next session? Ideally, I would want to code in next to next session. Okay, once I completed till ridge regression, I completed all the theoretical part, and then we can come to this. But what I can do is I will send you the code for this. Or let me do one thing. I'll take one coding section next time, and then we'll come back to theory. Otherwise, it will get elongated. Is it okay? So next time when you come, please come with your proper chargers and everything. We'll do some coding here, and then maybe some part will start again with the theory, and then again we'll complete the theory, and then again we'll come to coding. Is it okay? Okay.
Sir, if possible, next sentence include the scaling, standardization, normalization also, and along with underfitting, overfitting. Some slight idea with this sort of,
I don't see why. I mean, the problem is actually you are ahead. So I think if I have a structure in mind. So if there it doesn't follow, you can tell me. It's not required currently. I will give a data set where it is required. Okay. So when we do classification and all, that time normalization and all will become important. Yeah.
Is there some book which you prefer?
So I have given one book that is for data analysis, and there is one book called ISLR. SLR.
That is the core statistics book, right?
Yes, but it is covering the machine learning part well. I'll just show you. I can give you the PDF. Also, you can find it out on.
You are talking about this Python data for analysis.
Yes, this is one book for data analysis which I have given.
Some other book of statistics. ISLR, another book of statistics.
It is a Bible for me, to be very frank. So it's not just another book, it is a very big book, and it is the mother book. Okay, so in that the code is written in R. Okay, what I want you to do is, don't worry about the theory part is also covered well in that. Okay, Introduction to Statistical Learning. It's a very good book. So you can refer to it in your free time. You can download it anywhere. If you just search ISLR PDF, you will find lots of links on it, or I will send it. So this is what they have done is they have coded with R software. We will do with Python. So this is a very good book. I will say refer to it once. And then there are more other books, but all books are derived mostly from this book. So if you see, machine learning is inherently nothing but a statistical It is nothing but statistics on and optimization. There are only two things happening. Okay. Standardization, normalization, I plan to cover in classification. Okay, because that time it impacts your model. In regression, it doesn't impact your model so much. So when the time, so that they understand better, I will bring it there.
Sure.
So, yep.
Thank you for watching this video. We'll be back with some more tutorials very soon. Stay tuned.